Hi everyone, in this video we are going to learn about electrical analogies of a mechanical translational system. We are going to look into the guidelines. As we all know that in case of modeling of a mechanical translational system, we have used mass, dashpot and spring, which are analogous to resistance, inductance and capacitance of the electrical systems. The input force in a mechanical system is analogous to either voltage or current in an electrical system. Likewise, the output velocity, it is nothing but the first derivative of the displacement in mechanical system is analogous to either a current or voltage in an element in an electrical system. Accordingly, we have two types. So we are having a two types. One is basically a force voltage analogy. Another one is force current analogy. So we will see one by one. Force voltage analogy. Here, in case of the force voltage analogy, the input in case of the mechanical system is a force which is equivalent to voltage source in electrical system. Output is a velocity. In case of an electrical system, it is a current through the elements. Now you see here all the inputs are force which is replaced by an E, means that it is an voltage source, and all the displacements are represented in terms of the velocities. We take a dash part. The opposing force is directly proportional to velocity. So that's why dx by dt is represented by V. The dash part is equivalent to resistor in case of the electrical system. Here I have represented the voltage across this resistor, and mass is equivalent to inductor. Acceleration is nothing but dv by dt in terms of velocity. And the spring, the displacement is represented in terms of the velocity as integral v dt. The spring is equivalent to a capacitor in the electrical system. Next one is force current analogy. In force current analogy, the input is a force in case of a mechanical system. Electrical system, it is current source. Output is velocity. In electrical system, it is voltage across the element. The dash part is represented by resistor. The mass is represented by capacitor. Spring is represented by inductor. All the forces are replaced by the current source in case of an electrical analogous circuit. We are representing the displacement x in terms of the velocity. Let's see what are the steps we have to follow in order to achieve the electrical analogies of mechanical translational system. If we are given with a mechanical translational system, first you have to draw the free body diagram at each node, that is at each mass. Using force balance equation, write the differential equation governing the mechanical system. Then replace all the displacements in the differential equation in terms of its velocity. Then we have to draw the force voltage electrical analogous circuit. Next, we have to draw the force current electrical analogous circuit. How to draw these electrical analogous circuits? First we will see how to draw the force voltage electrical analogous circuit. In electrical system, the elements in series will have a same current. Likewise, in mechanical system, element having same velocity are said to be in series. Each node in the mechanical system corresponding to a closed loop in an electrical system. The number of masses in the mechanical system is equal to number of meshes. And we have to consider all the elements in the mechanical system whose equivalent electrical analogous elements has to be represented. If suppose in mechanical system the elements are appearing between the two masses or a common element between two meshes in case of an electrical system. And as we know that in case of the mechanical translational system, input is a force which is equivalent to an voltage source in an electrical system. Output is a velocity. In case of an electrical system, it is current through the elements. In force voltage electrical analogous circuit, masses are represented by an inductor, dash part is represented by resistor, a spring is represented by a capacitor. Once we get a force voltage electrical analogous circuit, we have to write the mesh equation. To write that, we are going to use the Kirchhoff's voltage law. Let's see how to draw the force current electrical analogous circuit. In case of an electrical system, the elements are in a parallel will have a same voltage. Likewise, in mechanical system, elements having the same force are said to be in parallel. Each node in mechanical system is a closed loop. In electrical system, number of masses is equal to number of meshes in electrical system. All the elements which are available in the mechanical system will be represented by means of its electrical analogous elements. If suppose the elements connected between two masses will appear as a common element between two nodes in case of the force current electrical analogous circuit. Next, we know that input we are going to apply to this a mechanical system is a force. In case of an electrical system, it is current source. Output is a velocity. In electrical system, it is voltage across the element. In force current electrical analogous circuit, mass is represented by a capacitor, dash part is represented by a resistor, a spring is represented by an inductor. Once we get a force current electrical analogous circuit, we have to write the nodal equation. To write the nodal equation, we are using the Kirchhoff's current law. So this is how we have to obtain the force voltage and force current analogous circuit. These are the references. Thank you.